Dear students, you're most welcome in the class of Mathematics by N.K. Dikshit. In the previous lecture, we have completed the equation of line and problems based on equation of line. Now today we are going to start the topic plane. So we will study what are the different forms of equation of plane and how to solve the questions related to plane. So to find a unique plane, there are three different situations to find the equation of plane. Let us start. To find the unique equation of plane, there are three different forms. So we can say a plane is determined uniquely if any one of the following is known. The first situation is the normal to the plane and its distance from the origin is given. And second one is it passes through a point and is perpendicular to a given direction. And third one is it passes through three given non-collinear points. So one by one I will take all the three equations of the plane. So first of all, let us take equation of a plane in normal form. So you can see here there is a plane whose normal vector is given, means the perpendicular drawn from the origin to the plane is given, that is ON. P is a arbitrary point, or we can say it is a general point on the plane. So let us find the equation of this plane. Now consider the distance, that is the perpendicular distance from the origin to the plane is D. It is represented by ON. So consider a plane whose perpendicular distance from the origin is D. Here D is not equals to 0 because D is the perpendicular distance from the origin, and if D is equals to 0, it means that plane is passing through the origin. So here ON is the normal from the origin to the plane. ON is the normal, means perpendicular drawn from the origin to the plane. Then we can say ON is equals to D dot unit vector n, where unit vector n is the along the ON, where n is unit vector along ON. That's why ON is equals to D dot unit vector n. Now you can see here, if we join P and N, then Pn lies in the plane and ON is perpendicular to the plane. So NP and ON both are perpendicular. Let P is any point on the plane, P is any point in the plane, then vector NP is perpendicular to ON. So NP dot ON, the dot product of these two vectors will be 0 because these two vectors are perpendicular to each other. If two vectors are perpendicular to each other, then their dot product is 0. Now, what is the NP? You can see here, to find NP, it is equals to OP minus ON. So the vector NP can be written as vector R minus vector ON, and ON is equals to D dot unit vector N. So in place of NP we can write R minus D dot unit vector N, and the dot product with D dot unit vector N is equals to 0. Now since D is not equal to 0, so we can take R minus D dot unit vector N dot unit vector N is equals to 0. Since D is not equal to 0, it is given. Now if we open the bracket, we get R dot unit vector N minus D dot unit vector N dot unit vector N is equals to 0. Now you know that unit vector, when it is multiplied by itself, the dot product of a unit vector by itself, it is always 1. So R dot unit vector minus D, because N dot N is equals to 1, it is equals to 0. So R dot unit vector N is equals to D. This is equation of plane in vector form. This is equation of plane in vector form. Now we want to convert this equation in Cartesian form. So this is the vector in Cartesian form. Let the vector OP is equals to R, that is xi plus yj plus zk, and the unit vector is li plus mj plus nk. Because if a unit vector is given, then the direction cosines of the vectors are given. So if we put the values of these vectors in the vector form, R dot n is equals to D, then we get xi plus yj plus zk dot li plus mj plus nk is equals to D. So after taking the dot product, we will get it is Lx plus my plus nz equals to D. This is equation of line in normal form, you can say in the Cartesian form. So this is equation of line in normal form. So here L, M, N are the direction cosines of the normal to the plane, and D is the perpendicular distance of the plane from the origin. Now if equation is given in the form like this, R dot AI plus BJ plus CK is equals to D, is the vector form, if it is the vector form of a plane, then AX plus BY plus CZ equals to D is the Cartesian form, or we can say Cartesian equation of the plane, where A, B and C are direction ratios of the normal to the plane. Okay. Now let us see the second form of equation of plane. So we are going to find equation of plane that is perpendicular to a given vector and passing through a given point. Let a plane pass through a given point A. So here this is point A, plane is passing through this point, and the position vector of this point A is small a. The perpendicular to a vector n, this plane is perpendicular to a vector n. So here this vector n is perpendicular to the plane, means it is making 90-degree angle with the plane. Now let R is a position vector of any point P. So P is a general point, lies in the plane. Its coordinates are x, y, z. So its position vector is small r. Now you can see here the OA vector plus AP vector, it is equals to vector OP. So we can say the vector AP is equals to vector OP minus vector OA. So vector OP can be written as R and OA is A. So this is vector AP. Now the vector AP is in the plane and vector n is perpendicular to the plane. It means vector AP and vector n are perpendicular. Now the vector AP is perpendicular to the vector n. Therefore AP dot n is equals to 0 and vector AP can be written as r minus a dot n is equals to 0. So this is the equation of plane passing through a given point and perpendicular to a given vector. So this is the vector form. Now to convert in Cartesian form, put the general vector r is xi plus yj plus zk, and the point from where the plane is passing, that is x1i plus y1j plus z1k, and the normal vector is taken as ai plus bj plus ck. So on placing the values r minus a dot n, so r minus a will be x minus x1i plus y minus y1j plus z minus z1k, and the dot product with the normal vector, that is ai plus bj plus ck, it is equals to 0. So we get a into x minus x1 plus b into y minus y1 plus c into z minus z1, it is equals to 0. So this is equation of plane passing through a given point x1, y1, z1 and perpendicular to a vector whose direction ratios are capital A, capital B and capital C. So this is the equation of plane in Cartesian form. Now we have to find equation of plane that is passing through three non-collinear points. Let three non-collinear points are A, B and C. whose position vectors are small a, small b and small c respectively. Let P is any point on the plane whose position vector is small r. Now you can see these 3 points A, B and C are non-collinear and lies in the plane, and P is a general point which is also lies on the plane whose position vector is small r. AP is equals to r minus a. You can see here, if we find the vector AP, then it will be r minus a. Now AP lies in the plane, and if we take these two vectors AB and AC, which are also lies in the plane. Now AB and vector AC also lies in the plane. Now you know, if two vectors are there and their cross product is always perpendicular to both the vectors, so AB cross AC will be perpendicular to the plane, because AB and AC both lies in the plane, so their cross product is the perpendicular to both, so it means it's perpendicular to the plane also. So the vector AP and the vector AB cross AC, these are perpendicular. So vector AP and the vector obtained by the cross product of AB and AC are perpendicular to each other. And if these vectors are perpendicular, then their dot product is 0. It means AP dot AB cross AC is equals to 0, and the AP is equals to r minus a, and AB can be written as B minus a, AC can be written as C minus a. These are the position vectors. It is equals to 0. So this is the vector equation of the plane which is passing through three non-collinear points. Now to find the Cartesian form, let us take for Cartesian form, the vector r is equals to xi plus yj plus zk, and vector a is x1i plus y1j plus z1k, vector b is x2i plus y2j plus z2k, and vector c is equals to x3i plus y3j plus z3k. So by placing the values in the vector form, we will get the equation of plane as x minus x1, y minus y1, z minus z1 in the first row of determinant, and in the second row b minus a. B minus a means x2 minus x1, y2 minus y1, z2 minus z1, and third vector is c minus a. It means x3 minus x1, y3 minus y1, and z3 minus z1. It is equals to 0. So by using this determinant, we can find the equation of plane which is passing through three non-collinear points, and these three non-collinear points are x1 y1 z1, x2 y2 z2, and x3 y3 z3 respectively. So now we are going to find the intercept form of the equation of plane. So let the equation of plane is ax plus by plus cz plus d equals to 0, and plane makes intercepts a, b, c on x, y and z axis respectively. It means the plane meets x, y and z axis. Plane meets x, y and z axis at the points a, 0, 0, 0, b, 0 and 0, 0, c respectively. Means the plane meets the x-axis at a, 0, 0, meets at y-axis at 0, b, 0 and meets at z-axis at 0, 0, c. Now it means these points satisfied the equation of plane. Therefore a into a plus b into 0 plus c into 0 plus d equals to 0. It means the value of capital A is minus d upon a. In the same way, the plane is also passing through 0, b, 0. So it is a into 0 plus b into b plus c into 0 plus d equals to 0. It gives capital B is equals to minus d upon b. Similarly, capital C is equals to minus d upon small c. Now if we put these values in the general equation of plane, then the equation of plane will be ax means minus d upon ax minus d upon b by minus d upon cz plus d equals to 0. So you can see if we take minus d as common, then we get x upon a plus y upon b plus z upon c minus 1 equals to 0. Because d is not equals to 0, this is the distance of the plane from the origin, so that's why x upon a plus y upon b plus z upon c minus 1 equal to 0, since d is not equal to 0. So equation of plane in the intercept form can be written as x upon a plus y upon b plus z upon c equal to 1. This is the equation of plane in intercept form, where the plane cuts the intercepts a, b and c on the coordinate axis x, y and z respectively. Now let us take a question. Question is, determine the direction cosines of the normal to the plane and distance from the origin. The plane is given 2x plus 3y minus z equals to 5. So we know that to make the direction cosines as the coefficient of x, y and z, we have to divide by under root of a square plus b square plus c square. So equation of plane is 2x plus 3y minus z is equals to 5. Dividing by square root of 2 square plus 3 square plus minus 1 square. So its value is 2 square is 4, 3 square is 9 plus 1, that is under root 14. So if we divide the equation of plane by under root 14, then we get 2 upon under root 14x plus 3 upon under root 14y minus 1 upon under root 14z is equals to 5 upon under root 14. So compare with the general equation, that is Lx plus my plus nz is equals to d, we can find the direction cosines are 2 upon under root 14, 3 upon under root 14 and minus 1 upon under root 14, and the distance of the plane from the origin that is d, which is equals to 5 upon under root 14. So in this way we can solve the question. So if any plane is given, then first of all take the coefficient of x by z, squaring them, add them, then take the square root, the number obtained, divide the whole equation by that number. So we can write the equation of plane in this form, where the direction cosines are given. Now I will take another question. Question is, find the Cartesian equation of the following plane, and the equation of plane in vector form is given r dot 2i plus 3j minus 4k is equals to 1. So to convert the vector form in Cartesian form, just write the value of vector r, that is xi plus yj plus zk. So we get xi plus yj plus zk dot 2i plus 3j minus 4k is equals to 1. This is the equation of plane. So take the dot product, it will be 2x plus 3y minus 4z is equals to 1. So this is the equation of plane. Now the next question is, find the coordinates of the foot of the perpendicular drawn from the origin to the plane. So see, this is the plane and this is the origin. The coordinates of origin are 0, 0, 0. So we have drawn a perpendicular to the plane. Let this point is P. Let foot of the perpendicular is P, whose coordinates are x1, y1 and z1. And the equation of this plane is 2x plus 3y plus 4z minus 12 equal to 0. Now we can find the direction ratio of line OP. So direction ratios of OP are you can see that if a line is passing through 2 points, then direction ratio of that line are x2 minus x1, y2 minus 1 and z2 minus z1. So the direction ratio of this line OP are x1 minus 0, y1 minus 0 and z1 minus 0. Or simply we can say the direction ratios are x1, y1 and z1 here. These are the direction ratio of line OP. Now the direction ratio of the vector normal to the plane are 2, 3, 4 with the help of equation of plane. Direction ratios of normal to the plane are 2, 3, 4. Now OP is also normal to the plane. It means OP and normal to the plane both are parallel. Therefore the direction ratios are in proportional. So OP vector and normal to the plane are parallel. So the direction ratios are in proportion. x1 upon 2 is equals to y1 upon 3 is equals to z1 upon 4, let us, it is equals to lambda. Then the value of x1 is 2 lambda, y1 is 3 lambda, and z1 is 4 lambda. Now because this point P lies on the plane, this point lies on the plane. So the x1, y1, z1 satisfied the equation of plane, that is 2x, that is 2 times of 2 lambda plus 3 times of 3 lambda plus 4 times of 4 lambda minus 12 equals to 0. Putting the value of x1, y1 and z1 in the equation of plane, we get 4 lambda plus 9 lambda plus 16 lambda minus 12 equal to 0. It is 29 lambda is equals to 12, then lambda is equals to 12 upon 29. So this is the value of lambda. Putting in x1, y1 and z1, we get x1 is equals to 2 lambda. So it is 24 upon 29. Similarly, y1 is equals to 3 lambda. So it is 3 into 12, that is 36 upon 29. And z1 is equals to 4 lambda. So it is 48 upon 29. So this is the these are the foot of perpendicular. Foot of perpendicular, that is 24 upon 29, 36 upon 29 and 48 upon 29. This is foot of perpendicular. If you have to find the length of perpendicular, then you can use the distance formula also and find the distance of O and P, but here only foot of perpendicular was asked. So it is complete. Now the next question is, find the vector and Cartesian equation of the plane that pass through the point 1, 0, minus 2 and normal to the plane is I plus j minus k. It means a point is given from which the plane is passing, and normal vector is given that is perpendicular to the plane. So the equation of plane passing through a point whose position vector we can write I plus 0j minus 2k, and normal to the plane, it is represented by capital N, so it is I plus j minus k. You know, equation of plane is r minus a dot n is equals to 0. So place the value here. It is r minus I minus 2k, that is the position vector of A, and dot I plus j minus k, it is equals to 0. So this is the equation of plane in vector form. To find the equation of plane in Cartesian form, place the vector r as xi plus yj plus zk minus I minus 2k, then dot product with I plus j minus k. So here we get x minus 1i plus yj and minus z plus 2 plus z plus 2 k dot I plus j minus k is equals to 0. So if we take the dot product, we will get x minus 1 plus y minus z plus 2 is equals to 0. So it is x minus 1 plus y minus z minus 2 is equals to 0. So x plus y minus z minus 3 equals to 0. This is equation of plane in Cartesian form. Now next question is, find the equation of the plane that passes through 3 points. These are 1, 1, 0, 1, 2, 1 and minus 2, 2, minus 1. Let these 3 points are A, B, C. So the coordinates of A are taken as x1, y1, z1 and these are 1, 1, 0. Coordinates of B, these are x2, y2, z2. So these are 1, 2, 1. Coordinates of C, these are x3, y3 and z3. These are the minus 2, 2 and minus 1. Now equation of plane that is passing through 3 points. Equation of plane passing through 3 points. That is given by x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equals to 0. So place the values here and simplify. X minus x1, that is x minus 1, y minus 1 and z minus 0. Now x2 minus x1. X2 minus x1 we can write 1 minus 1, that is 2 minus 1 and 1 minus 0. Now x3 minus x1, that is minus 2 minus 1, 2 minus 1 and minus 1 minus 0. It is equals to 0. So we get x minus 1, y minus 1 and z. Here it is 0, it is a 1, 1 and it is minus 3, it is 1 and it is minus 1 equals to 0. Now simplify, open the determinant. X minus 1, we get it is minus 1 minus 1. Then negative sign, y minus 1. So it is 0 plus 3. And plus z times it is 0 plus 3 is equals to 0. Simplify, it is minus 2, so we get minus 2x plus 2 and minus 3y and plus 3 and plus 3z is equals to 0. So minus 2x minus 3y plus 3z and plus 5 is equals to 0. If we multiply by minus 1, then we get 2x plus 3y minus 3z minus 5 equals to 0. So we can write equals to 5. This is equation of plane that is passing through these 3 given points, 1, 1, 0, 1, 2, 1, minus 2, 2, minus 1. Now let us take another question. The question is, find the equation of the plane through the intersection of planes 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2 equal to 0 and the point 2, 2, 1. So first of all, see, if a plane is passing through the intersection of 2 planes, then we can find the equation of plane passing through the intersection of planes 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2 equal to 0. It will be 3x minus y plus 2z minus 4 plus lambda times x plus y plus z minus 2 equal to 0. This is the equation of plane that is passing through the intersection of these two planes. Now take it equation 1. This plane also passing through 2 comma 2 comma 1. It is passing through 2 comma 2 comma 1. So this point satisfy this plane. So place the value 2 comma 2 comma 1 in place of x, y and z. We get 3 into 2 minus 2 plus 2 into 1 minus 4 plus lambda times 2 plus 2 plus 1 minus 2 equals to 0. So we get here 6 minus 2 plus 2 minus 4 plus lambda times it is a 2 plus 2 plus 1 minus 2 equal to 0. So here we get this 2 is cancel out, 6 minus 4 that is 2, and here this 2 is cancel out, it is 3 lambda. So lambda is equals to minus 2 upon 3. So place this value here in equation first. So from equation first, required plane is 3x minus y plus 2z minus 4, and the value of lambda is minus 2 by 3. So it is x plus y plus z minus 2 equal to 0. So multiplying by 3 in the whole equation, we get 9x minus 3y plus 6z minus 12 minus 2x minus 2y minus 2z plus 4 equal to 0. So we get 9x minus 2x, that is 7x, minus 3y minus 2y, that is minus 5y, and 6z minus 2z, that is 4 times of z, and minus 12 plus 4, that is minus 8 equal to 0. So this is the equation of plane that is passing through the point of passing through the intersection of two planes, and also a point that is given 2 comma 2 comma 1. So in this way we can solve the various type of problems related to the plane. Okay, then solve the questions from your exercise and practice them. All the best. Thank you.